Good afternoon, everyone. My name is Binbin Cong, and I'm from EasyStack, and I'm focusing on the QA and DevOps things in our company. And this is my colleague.
I'm Liu Wei, also OA. I'm from China, and we from China, and I'm a test architecture, and I focus on the CI/CD and some test tools development. Thank you.
Today, we will introduce the DevOps implementation for OpenStack on Kubernetes. Let me take some minutes to talk about our company, EasyStack. We just got the Series C+ round with 60 million Canada dollar. And we have over 300 enterprise customers in China. And since our products are all built on OpenStack, so we'll contribute to the community. We are the members of OpenStack, CNCF, and Linux Foundation now. This is today's agenda. We will talk about the challenges we are facing and DevOps architecture of our implementation, the toolchain and development deployment of the DevOps architecture, and the things ongoing in the future. The challenges we are facing today is our product. We are trying to release the product on demand. The release should be rapid enough to satisfy our production needs. Each release we will have new features, patches, and upgrading support. So we should be able to release our product on demand. This is very challenging, as you know. The second one, to make our release production level, we will need to run tests for each patch and keep each high availability, reliability, and performance testing running on the platform continuously. Third one, we have OpenStack product. So if we don't support our own business on it, we can't prove that our product can support the customer's needs. This is the principle of eat your own dog food. So we need to build our own OpenStack platform with our product. And then we run our CI/CD and our business on top of it. For the upgrade is another challenging thing for our product. So we need to do continuous delivery on both testing and production environment to ensure the upgrading will not affect the business, to ensure our own platform than the customer's platform. Okay. Next, I will introduce our DevOps architecture. The first one will be CI, continuous integration. The same as upstream, our CI run PEP8, UT function testing, but to ensure what we tested was the same as what we released. We need to deploy the whole things with minimal nodes set in our cloud to execute tempest. And here, we build a tool to help us to deploy. We call it OS in OS. We will talk about it later. This CI will be triggered from a code commit. The PEP8 UT function testing will be run. If it passes, we will build an entire system, as I said, and then set up the environment, run tempest. If it passes, the gerrit will verify +1. If not, the gerrit will give a -1. Then the environment will be cleaned up. OK, this is the CD part. CD is the key to ensure that we release is matching the production requirement. CD will update our testing environment with each merged patch for all the components. And then send the notification via email, Slack, or some other ways, which we'll talk later. the event notification, event match things. There are lots of testing running in the test environment without interrupted during upgrading. So the CD is triggered by the code merge. And then we will build the images and then upgrade the test environment. We have several test environments, and we will upgrade them in parallel. Then we will run Ready and Tempest, the community things, maybe plus our own production features, run the Ready and Tempest testing on each environment. Then we will send the test result with Slack or email notification. The notification will include the testing results, which environment has been upgraded, if it has been upgraded successfully or not. If the upgrade failed, it will roll back to the previous version. This is the CD. The next one will be CD for the release. Our release procedure has two phases, the pre-release and the post-release. For the pre-release, we will have the input of a release note. We get the release note, we will know which part will be released. For example, the key components, Nova, neutrons, cylinder, keystone, those components will be released, and which version will be released. With it, we will fetch the builds from repository. Then we will compare the builds changelog with the commit message, commit ID in gerrit to make sure that the build from the repository is the correct one. We compare the changelog. If it passed, then we will build the packages. For example, the RPM packages, the image packages. The last step will be generate and commit our release file to the releases project. We are leveraging the community releases project to do the CD for release. Then the release commit, if the release commit is merged, then we will do the post-release things. First one will be tag all the projects. Maybe if we release 1.2 release, then we will tag every project to be 1.2. Then we will publish the packages to our repository. And then we will publish a release, maybe ISO things. The last step will be upgrade our production environment, as I said before. We need to ensure the upgrade progress won't impact anything in the production environment. Okay. And next, my colleague Liu Wei will continue, please.
Okay, I will introduce toolchain and deployment. So first of all, in the year past of the last, we built Zuul. We built our CSD with Zuul version 2.5, and also we deploy some Jenkins servers to run jobs. And at the last December, we upgrade our Zuul to V3. V3 dropped the Jenkins, so we must migrate our jobs from Jenkins to Ansible. Fortunately, as Ansible is simple to development, so we cost not much to migrate all the jobs. After that, we try to use Kubernetes to run Zuul and nodepool because if you got an image, like Nginx, you will run the web server very easily. So we try to do the same thing. Also, the Kubernetes provides lifecycle management, which reduces effort in maintenance. So we built the Docker file for Zuul, nodepool, and for some executors. To work with Kubernetes better, we built the helm chart, which contains all the configurations for the Zuul and the nodepool. And some of the runtime variables were imported in persistence volume. Sorry. Zuul, nodepool, and Zookeeper, and multiple executors will be deployed by these charts. And as you know, all configurations of Zuul are managed in the project config in the upstream. So we build some jobs and to update the configurations automatically after we get some change in it. And if code was changed, so there are some bugs in the Zuul. So if there are a patch we fixed, one job will be triggered by event mesh to check there are some running jobs in Zuul. And if there are no running jobs, and this job will update the Zuul code and restart Zuul server. Except project config, there are lots of jobs in Zuul jobs and OpenStack Zuul jobs. Most of these jobs are not used in our internal service. So we build our local project which contains all the jobs that we need, and we refactor some upstream jobs, and we develop some local jobs to support our CI/CD. Okay, OS in OS, which is meant to support our CI. OS in OS is OpenStack in OpenStack, just like the DevStack, but it's different. This OS in OS deploy one OpenStack with multiple nodes in OpenStack. The main difference of OS in OS with DevStack is that we try to build the same environment just like what we released to check all the code running as we expected in the customer environment. So this is the main difference. So this is why we build the OS in OS in our test environment. And the OS in OS is deployed by heat template. There are several templates with several configurations to deploy the OpenStack in our local private cloud. To deploy the inner OpenStack to the private cloud, it is some troubles like the network, how the network running in the in the inner OS OpenStack. We set some VLAN trunks to the networks which will be used in the inner OS. So this is make the OS in OS running with a multi-node. Okay, here's the some tools. Deployer is an auto deploy and auto upgrade tool for OpenStack. Also used to deploy OS. In fact, the deployer is one of our software production. We use this deployer in customer environment to deploy our production tool. Okay, event mesh. Zuul didn't provide much ways to extend his functions. So we integrate this event mesh to Zuul and executors, and this gives us the ability to extend whatever you want in your CI/CD jobs. Now we use this event mesh to do several things, just like notification. Now we can use this event mesh to send a notification to Slack message and to your email, and also we try to we build some jobs which are triggered by this event mesh to update Zuul itself. And Rally and Tempest also deployed to test our production. Chaos Monkey help us to do the high ability testings, and we still deploy some other testing tools to test hardware like CPU memories, and other tools like iPerf, IOmeter, FIO. All these test tools are managed by the CD process, and if some changes are merged and upgraded to our test environment, all the tests will be started. Also, there are some tests continuous running in our test environment without interrupted by the upgradation. So all these test tools and the continue running to make sure whenever we want to release, and we can release. Okay, next I will introduce some next step jobs. Okay, first is monitor and log analysis. Monitor is a basic system. Now we build some simple monitors to check our Zuul server and nodepool, which is running like what we expected. We want to build a whole monitor system, so not only monitor Zuul and nodepool, also Zookeeper, also other softwares. Also, our continuous running system is based on the hardware, so we also want this monitor system to monitor our hardwares, like network card and read system and storage, and CPU and memories. Log analysis is a main function for our CI/CD. As we expected, we want to build a log analysis system with Logstash and Elastic Research, which will analyze the log automatically and fire bug to our Jira automatically. Also, we want to build an all-in-one dashboard for CI/CD, which include our test jobs, test result, also manage our test cases. We use Jira to manage our storage tasks and bugs. Finally, we want to update the storage and tasks and fire bugs automatically when CSD done. And finally, we want to deliver this whole things to this whole things as a pass to our customers. In China, most of our customers want CSD server services. So all of this, some of these things are going now. Okay, that's all.